So look at question 11. They say state the value of r and alpha such that for 3 sine theta plus 6 cos theta, it is equals to r sine theta plus alpha. So means that we are going to express this form of expression trigo to a single trigo by using compound angle formula. So you can notice that this is the constant we want to find out what is our r, what is our alpha. So our r, when we getting our r, we will refer our r greater than 0, means we want the r positive value, and our alpha just the basic angle in quadrant 1, which is between 0 and 90 degree. So after we express it into the single terms trigo here, then only they say hence. Hence means use our results. Use our result in part 1 here to solve this equation. So firstly we go for the expression here. We express these two terms of trigo, which is sine theta and cos theta. They are already very simple. So express these two simple terms into a single terms compound angle sine. So from our questions, we take down our question where 3 sine theta plus 6 cos theta can be equal to the form of r sine theta plus alpha. So we use our compound angle when we have sine theta plus alpha. So this is sine A plus B. Our A is theta, our B is alpha. So we expand this compound angle, we will get sine A cos B. If you're using operation plus, then we'll follow to plus cos A sine B. So from here, our expanded compound angle, it will become sine A, where our A is theta, and then cos B, B is our alpha, plus cos A is theta, then sine B is alpha. Then we expand our constant r here, the coefficient r here, we expand some more, it will equals to r sine theta cos alpha plus r cos theta sine alpha. So notice that after we expand our compound angle formula here, we can get into the term of this 3 sine theta plus 6 cos theta. So look at here carefully. The sine theta part is this part. So 3 is times with the sine theta, meaning that our r cos alpha is 3. So another terms we can refer here, they are similar, cos theta. So cos theta is here. Cos theta is here. So you can see cos theta 6. So means this r and sine alpha is 6. So our purpose here is we're going to find out what is our r and alpha. So we have two unknown to form, means we need two information to go to build out our simultaneous equation. So by looking at this expanded form, we compare back with these questions. When we compare, we can get r cos alpha equals to 3. That will be our first information. Another comparison is r sine alpha equals to 6. So two equation for solving two unknown, which is r and alpha. So after we get r and alpha, this form of trigo can be expressed in a single term of trigo. So after we get two equations, so now we're going to solve these two simultaneous equations to find out what is our r and alpha. So how to solve these two simultaneous equations? We are going to solve for alpha first. We will eliminate r. So how to eliminate r? We will use division, and we will divide equation 2 and to equation 1 so that we can find tangent. So you can see when we have equation 2 r sine alpha divided by r cos alpha, it is equal to 6 divided by 3. So we choose the equation that have sine, divide by the equation that have cos. So when we divide like that, you can notice that our r will be automatic eliminate, leaving the constant alpha we need to find. So our constant alpha here we can find off using the trigo tangent, which is equals to 2. And then this alpha we can move our tangent, shift 2. So straight away we can get the answer. So you can see, is it using radian or degree? We look at our questions. If our question starting with degree, then we will use our answer in degree. If our questions here starting here, they write a pi here, means we have to set our calculator into radian, then our answer also need to be in radian. So for these questions, they are focusedly in degree, so we continue with degree form. So this alpha will give us 63.43. So we get one of the unknown already, which is our alpha. So once we get our alpha, then we continue how to get our R by eliminate our alpha. So here we have another formula we have to know here, which is identity formula. Where in identity formula, it has sine square theta plus cos square theta that can equals to 1. So for my equation, I want to eliminate our alpha. I want to eliminate our trigo here. I can put equation 2 square plus 1 square. So once I square this equation, it will become r square sine square alpha. So I square this equation 1, it will become r square cos square alpha. So the value here will be 6 square plus 3 square. We can factorize out our r square, then we can get identity formula. Sine square alpha plus cos square alpha. So this will be equals to 45. So our cos square alpha cos square plus sine square here will be equals to 1. So that's why we eliminate our alpha constant, then we get our r square equals to 45. So our r here will be equals to square root 45. So we're not taking negative value because they say R, they only focus for positive value. So normally when we move square to the right hand side, we will have positive, negative. So for this part, we don't need. We straight away get the positive value. So now we solve. We done our simultaneous equation where our R and alpha we already get it. So therefore, we back to our questions there where our 3 sine theta plus 6 cos theta, these two trigo terms can be expressed into the single term, which is r is square root 45 sine theta plus alpha. So r sine theta plus alpha. So this will be a better represent for these questions because it is leaving one single terms here. So later on we can solve for the value square root 5. Okay, so we focus now what is important marks that we have to be careful. So for of course for the first part is finding our R and alpha, because this question they combine together with solving, so the marks for this representation a bit less marks at here. Then most focusing at here. So getting our alpha and R here will get you 2 marks. Then we continue for hand solving. So for solving, when our question 3 sine theta plus 6 cos theta equals to 5. So how to solve this? We must achieve to a format of trigo angle value. So if you want to solve our trigo, we must have trigo in the bracket angle then equals to a value. So from here we can apply our 4 steps. First is about our range, second about quadrant, third about basic angle, then fourth about the angle rotation to get back our solution. So from here, this is our trigonometric equation, which is equals to value of sqrt 5. So for this format, we cannot solve anything. We use the latest version of this expression, which is square root 45 in compound angle sine. So now you can notice that our trigo now becomes single trigo already. From just now, we have two trigo terms. When I use this r sine theta plus alpha, I just only have one trigo terms. So we have to achieve this format trigo angle value, where this trigo I already get single trigo, angle is here, so value sqrt 45, we simplify to the right hand side. So when we simplify to the right hand side, it will give us 1 over 3. So we continue, we can see now we already achieved to this format, trigo angle value. So we can start doing our solving. So how to solve this equation? How to solve this trigonometric equation? First, we look at the range. So first step, we look at the range. What's the range? That means here, means we look at the questions. What's the theta range they want? They want 0 until 180. So our range here will be 0. Our theta here will be in between 0 and 180. This is come from the question. The condition come from the questions. But our latest solution here, you can see this is no longer theta. So you can see our angle here is no longer theta only. Our angle here is theta plus 63.443. So means our latest range here, theta will plus 63.43. So the minimum value and maximum value also will change. So when theta plus 63.43, 0 here also will plus, it will equal 63.43. And this one, 180 also will plus 63.43. So our range will be follow our latest form of our solution here. So our range here will be starting from 63 until 243 something. So this is the minimum solution we can accept, and this is the maximum solution we can accept. So this is the use for the range, so that we can know how far we can rotate. So we will start from quadrant 1, we will not start from 0, we will start from quadrant 1, start from angle 63, and we start rotate our answer. We find out our rotation until 243, means until quadrant 3 only. Then step 2, so step 2, we're going to focus our quadrant when sine value positive. So all sine teacher crazy. What we memorize here is for the value. This is all trigonometry positive. This is sine only positive. This is tangent only positive, and this is cos only positive. So when we see our solution here, we can see sine is in positive, means our angle involving here is quadrant 1 and quadrant 2. Then we go for step 3, basic angle. So for finding basic angle, we just need to shift our sign to the value. So remember, our value here, we won't take negative. We won't take negative, just like the argument we done in chapter 1. The argument, the angle we done in chapter 1, shift tangent b over a. B over a cannot take negative. So only positive number. We want to find out the basic angle here. When we have shift sine 1 over 3, we can see our basic angle here is 19.47. So where's the basic angle located? In quadrant 1 is here, quadrant 2 is here. So here will be our quadrant 1, Here will be our quadrant 2. There will be our basic angle. And then, so finally, we go for the step 4. So step 4 means our answer. So when we shift our sign to the right hand side, our answer here is theta plus 63.43. So what is the solution here? We have to rotate our quadrant, then we can see. So for our rotation here, we refer back to our range. It starts 63.43. You can see 63.40. I'm not starting from 0. So when the range here start from 63.43, my angle here in first quadrant is no longer involved because this angle only 19. 19 is less than 63.43. Our angle start from 63.40 and then they start rotate until 200 something. So for quadrant 1 here is already not involved. Then we continue. When you have rotation 63, go for quadrant 2. Yes, quadrant 2, this angle is involving. So for angle in quadrant 2, it will take basic 180 minus basic angle. So when our rotation go for quadrant 3, there's no solution, then they'll stop here, no longer anymore. So this is the usage of our range. We know when we start and when we stop for our rotation. So inside the rotation, if our quadrant involved in our answer, that means that has an angle there. So I only have one answer angle here in our rotation. So lastly, simplify our answer. So means that 180 minus and then minus this 63.43. So this will give you 97.1 degree. So we see what is important here. Of course, the first one, use concept of using the correct format that we're going to solve, which is using this single trigo format. And then finding the basic angle, we also have 1 marks. And then get the correct rotation and simplify to the answer. So you'll notice that normally our first step and second step, you don't have any marks. So but these two steps is important for us to determine our answer for this, because without the range and without the quadrant, we hardly to see where is the solution. So therefore step 1 and step 2, we have to write it in order to help us to identify our angle rotation as our solution in this equation. So that's all.